Okay. All right. Instagram guys, go to MikeHolt.com/live. Here we go. Brian, let me know when you're ready to go. Okay. Hi, I'm Mike Holt with MikeHolt.com, and I'm doing a whole series of videos every night for a few weeks. So go to MikeHolt.com/live so that you can see what the schedule is going to be. Okay, we're not going to get in the schedule. All right, let's get into today's program. First thing, I just want to take a moment to thank God for giving me the opportunity to do this, to make a difference in people's lives, and He's also blessed me, and hopefully I can continue to bless others. Let's review this again. I got a bunch of comments after I got done last night about the Romex bundling and running through a framing member. Okay, how many NM cables can you run through a framing member? And here was the question. Mike, I failed an inspection because the inspector said that we were limited to no more than 4 NM cables per opening, meaning, kind of like a drill a hole through wood or maybe the metal framing members. We had 7 Romex 12-2 cables going through 1 hole in a 2x4 stud. Okay, and then I mentioned, I'm going to add some graphics here. So let's just talk about 310.15C1. That's in the 2020 code. I don't know what number it is in the 2017 code. And what that says is whenever you have 4 or more current carrying conductors in a raceway or a cable without maintaining spacing longer than 24 inches, if you take Romex and you run it through metal framing members and you separate them so that they're not maintaining, so you're maintaining spacing, well then the adjustment factor we're going to talk about in some cases doesn't even apply at all. So first of all, let's understand that. So you have to have not maintained spacing for 24 inches or more. The ampacity contained in table 310.16, which used to be 310.15B16, must be reduced per table 310.15C1. So there's a table on the number of conductors that you're going to be bundling together that's going to be 24 inches or more, or rather more than 24, longer than 24 inches. Then you're going to have to adjust the ampacity. Why is this? This is because if you have 3 conductors, and if you go to table 310.16 or 310.15B16 in the 17 code, and if you read the notes and the rules in there, it says that 3 conductors, there is no adjustment factor. That's because the way the table was designed on the ampacity was based on 3 conductors within a raceway or a cable. So those are the ampacities. If you go more than 3 conductors, then we have to adjust the ampacity. We don't derate, we don't use that word, okay? That's for another group of people. Those are the guys we're not gonna talk about. So in our example here in the graphic is that we have 1, 2, 3, 4, 5, 6, 7. We have 7 current carrying conductors. And if we go to table 310.15C1 table, you can go look at your code book, or you'll see the table in your 17 code book, just right around that section right in there. I think it's B2 or something like that. And it's going to be a certain adjustment. Now, this adjustment does not apply to a raceway. If you're not going more than 24 inches, then this adjustment factor does not apply. So if you're in a raceway, code calls it a nipple, 24 inches or less, then this adjustment doesn't apply. Why not? I don't know. Where did 24 inches come from? 2 feet, it's a round number. Hey, maybe in another country they might use a meter because that's a convenient number. So, but the logic is this, that, well, yeah, you have a lot of conductors in a raceway, but if it's not that long, then those conductors can act as a heat sink and take the heat out to the conductors that's outside the raceway. Listen, that's the best I got, and it doesn't really matter. If it's 24 inches or less, we don't make any ampacity adjustment. Don't have to worry about why. Now, it's very common, let's say for services and nipples, wireways, where you want to try to get a lot of things. Another example is a lot of times I've seen contractors, my son did this when he did a medical job one time. They ran all the MC cables to the panel, but they went to a wireway, a little 4x4 wireway by, I don't know, 2 feet or whatever the case. They brought all the MC cables inside the wireway, and they had like a 2-inch raceway from the wireway into the panel board. And of course, they didn't cut the conductors in the wireway. They just, disconnected the sheath, put them in the connectors, They brought them all together, brought it into a 2-inch raceway, not longer than 24 inches. We don't have to adjust the ampacity. Just kind of bringing that concept so when we get to that question about the Romex, we have a better idea. Okay, I mentioned yesterday that a neutral conductor, if it's a 2-wire circuit, well then hot current goes out, current comes back. Well, the neutral will be a current carrying conductor. But if it's a 3-wire or a 4-wire circuit, multi-wire branch circuit, meaning multi-wire, 3 hots, 2 hots at a neutral, 3 hots at a neutral. We talked about multi-wire branch circuits yesterday, that neutral conductor is not considered a current carrying conductor unless, we're not going to get into the rule there, it's right there in 310.15E, it's probably 2, maybe 3, unless that neutral conductor carries a major portion of the load nonlinear. Pretty much in a residence, well, no, for example, there is no nonlinear loads as far as loading concern on a 3-wire circuit, 2 hots at a neutral. Nonlinear loads only become a concern because of the odd triplet harmonic currents. We're not going to get into that, which are going to be additive. They're not going to cancel. So therefore, if you have nonlinear loads and it's a major portion of the load, so if you have a 400 amp service and you have over 200 amperes worth of neutral loads that are nonlinear, and pretty much everything nonlinear. If you don't know what linear is, you need to get my fundamentals book that explains what that's out. Okay, neutral conductor on a circuit is not considered a current carrying conductor, except 2-wire circuits. And a question said, hey, Mike, my inspector said that you have to count the ground wire as a current carrying conductor. And I'm like, oh my gosh, you gotta be kidding me. 310.15F. No, an equipment grounded conductor is not a current carrying conductor, so we don't count equipment grounded conductors. All right, so now back to the question about 7 NM cables, 14 gauge conductor. That means each cable has 2 conductors times 7 is 14 conductors. And if we go to the table, 310.15C, I think it's a C1 table right in there. It's going to tell you for how many conductors. I didn't even show the number of conductors here. Huh? I should have showed here. For 14 conductors, it's 50%. And I mentioned that you go to table 310.16 in the code book, and when you go to the code book, you go to the 90° C column, always for anytime you could adjust the ampacity conductor or anytime you're going to correct the ampacity conductor, and that's another topic. We're not going to cover that now. So 12 gauge wire, a lot of electricians think that 12 gauge wire is rated for 20 amps. No, it is not rated for 20 amps. It's rated for 20 amps at certain temperatures, and it's rated for 30 amps at certain temperatures, depending upon what you're going to be doing with it. Since we're adjusting the ampacity, we're going to go to table 310.16, and we're going to look it up, and we're going to find out 12 gauge wires rated 30 amps. We saw the adjustment factor in the table, which is before table 310.16. It was going to be at 50%, and 50% of 30 amp wire is 15 amp wire, so no, you cannot put it on a 20 amp circuit. But then I got a bunch of comments, and I couldn't get the comments quick enough last night. But Mike, if you go to 334.80, you guys can make a note here. Watch this. By the way, this is only good for 24 hours, and this thing just goes vaporized. So if you're going to watch the video a second time or third time, you better get this thing after it gets downloaded and watch it soon. But 338.4 says the only time that we actually have to to adjust the ampacity of Romex is whenever you're going to put some kind of foam or sealant in where you're kind of going through it. And I think, with the energy code, a lot of times you'll see outlet boxes will have the foam around it on the outside of the box, and the cable, when it kind of goes up through, let's say, to the center, going up and through the ceiling, they'll foam it right there, maybe going into a panel because it's going to be going up in the attic space. So anytime you foam it and you have more than 4 cables, then you're going to have to go to this 50% adjustment factor, and that's a no-no. Now, are you kidding me? You spray foam, and that somehow on that 2x4, that's actually not 2x4, that because you went through a 2x4 and you sprayed foam in it, you have to adjust the ampacity. Of course, it doesn't make any sense. So why is that, Mike? The guys that hate aluminum wire, they like driving ground rods at poles, the Neanderthals, okay? These people hate Romex. Anything they can do to screw Romex, that costs more money, then they're going to do it. Of course, it makes no sense to adjust the ampacity of Romex any more than it would be if you ran service entrance cable or MC cable or any other wiring method, but that's just the way it is. So going back on our example, that if you spray the foam, then we have to do this. If you don't spray the foam, you're just running it all over the place, put as many wires you want to. And we're going to talk about some other ways to get in that raceway or into that panel board. All right. What if you put 4 cables? Well, 4 times 2 conductors that are current carrying, 8 current carrying conductors. Go to table 31016. Holt.com/live. That way you can see the graphics. Okay, those of you that are watching this on Facebook and on YouTube, we haven't figured out. Brian House is obviously an amazing guy, and he's doing all the technical in the background, and we can't figure out exactly why sometimes it drops out. So we got to deal with what we got to deal with, and eventually we're going to make this work. And Brian is in Florida, and I'm in New Mexico, so it isn't like I got to press buttons for him. All right, back to where we were. All right, yesterday was a question about, Mike, can you use like a 2-inch cable clamp and run all kinds of Romex conductors through that? I'm like, no. So let's review it one more time. The basic rule of 312.5c says cables must be secured to the cabinet with fittings designed and listed for the cable. Okay, well, here's an example. I think this is, I don't know who makes this, probably Arlington. Here's a cool fitting that is specifically listed and identified for multiple cables. They'll tell you what size conductors, how many conductors. So that is fine. That's not fine, because the code says you have to terminate the cables with fittings identified and listed for the cable, and that's not legal. So there's an example of, no, that fitting, and of course 110.3b says you have to use fittings in accordance with the listing and labeling instructions, and of course that's not listed for that. Now, one of the guys on the streamers last night sent me an email and said, but Mike, what about 312.5c and the exception? And I'm like, all right, let's review what this rule says. It says, hey, listen, if you want to run a bunch of NM cables, instead of like doing that, put like a little sleeve of pipe and get the sleeve going up, like I said yesterday, I really like. If you want to do that, and here's what you got to do. The cable is fastened within 1 foot of the raceway. Okay, no big deal. The raceway does not penetrate a structural ceiling. Okay, there's a structural ceiling. I'm trying to think what a structural ceiling is. I don't know what a structural ceiling is. I guess that means I can't go maybe to the 2nd floor. I don't know. Fittings are at the end of the raceway to protect the cable. You know, that's kind of complicated. Here, I got a little piece of EMT sleeve on the right side. I guess I put an EMT connector and then put a fiber bushing on there. Then on the PVC, fittings at the end fittings are at the end of the raceway to protect the cable. You know, I don't know about that PVC coupling, and I think that's not going to be it. So I'm going to ask Mike Corbett, my graphic designer, who's watching this, let's change that to, wow, what could you use? I guess you'd have to put a PVC coupling. No, put a PVC, no, I'm sorry, a PVC connector on there, because see, there's nothing in the code that tells us exactly what kind of fitting to put on the end there. Fittings are at the end of the raceway to protect the cable. So that's going to be a 90.4, the authority having jurisdiction. You're putting in cables. It isn't like you're putting in conductors. You know what I mean? There's a difference in pulling conductors in a raceway than there is putting in cables. And basically you're not really pulling them, you're just kind of pushing them down, because you can see there's a maximum length of. So I don't know what the authority have in jurisdiction. To me, if I was the inspector, you got a piece of PVC, whatever you put on the end, I don't really care, or nothing. And then it goes on, the raceway is sealed. Okay, so you take a little foam, make sure you use foam that's not going to damage the conductor, and it's specifically identified to be used with electrical conductors. That's another rule. The cable sheath is not less than a 1/4 inch inside the enclosure, not less than a 1/4 inch. I could put 10 inches in there if I want to. Okay, probably not, but you have to have that in there. And the raceway is secured. I think there's, guys, go to 312.5C. I think that graphic is missing in there. You know what? I really don't like me not using a code book. It was really bothering me yesterday. They say, I think it's this rule, I think it's that rule, because between the 2020 code and the 2017 code, there's been a lot of changes in Article 310, which is where I spent a lot of time. 312.5C exception. I thought this exception used to say that there was only permitted on surface mounted wire methods. Let me read it. Each cable is secured. The raceway extends directly and does not penetrate a structural ceiling. The fitting is at each end. The raceway is sealed. The raceway is continuous. The conductors are continuous. The raceway is fastened at the outer end and at the other points. The installation of the conduit tubing and cables does not exceed the percentage. Well, let me read the starting definite. Cables with it. I'm reading 312.5C exception. Code book. Cables with internally non-metallic sheath. Oh yeah, okay. It wasn't. It's the charging text of the exception that has these numbers below that, and it is a surface-mounted enclosure. Great. Look at this enclosure. It's surface-mounted. So let's make. Oh, actually, there is a point there. So we need to make a point that this is required to be a surface-mounted enclosure. Well, how many times are you going to have Romex run on a surface-mounted enclosure and you're going to sleeve it up? Oh, but if you put it inside the walls and you put drywalls on it, the electrons know the difference, and you can't do that. Yeah, listen, sometimes the code doesn't make sense, but you have to remember something. A lot of people hate Romex. And so if this is the way to stick it to Romex, though it doesn't make any sense, they don't care. I'll make a public input to change this to say, look, guys, come on. What does it matter if it's surface mounted or if it's concealed? It's the same thing. But watch, I can have all this attitude I have, which is fine. But this is what the code says. I'm not going to argue with an inspector. I'm not going to have a concealed raceway, sleeved up, follow all these rules, have the inspector turn me down, and then give the inspector a bunch of crap because I wasn't reading the code. Your job is to be the expert. You are supposed to know the code book. The inspector's not, he should be able to just go out there and talk to you, have a good old time and say, hey, what a great job. Not out there finding all these code violations because you don't know and you want the inspector to be teaching you and you're all upset about it. I'm getting off that topic. Okay, done. Fault current calculation. The question is, what's the formula for calculating the available fault current values required by 110.16b and 110.24a? I'm not going to get too deep in all these rules here, but let's just understand this is covered in the electrical theory class that I have. So I'm assuming you already know electrical theory. So everything I'm saying is, yeah, I know. Mike, keep going. You're going too slow. Okay. And so you might need to back up if you don't have it. The available fault of a power supply is going to be limited on the output to the input available fault, the impedance of the transformer, the voltage of the transformer, and the kVA of the transformer. So an example here, this is showing that it's 24,000 amperes available fault. Now you can contact the utility, give them an address, say, hey, listen, I have this address. What's the available fault at that transformer? So now we're talking about if there was a fault, there's 24,000 amperes of available fault, and you better make sure that the equipment you have is rated for that 24,000 amperes. However, you are going to be running conductors between the transformer and the premises. Let's say this disconnecting means, okay? Probably should show, well, we're not going to show a meter here because we're just going to show a disconnecting means. Because the conductor has impedance, it has reactants, all covered in theory. It has a certain length, okay? And it's aluminum, or it's copper, or it's in a metal raceway, or it's in a PVC raceway. So you have all these different factors. And then you'd have to have software to say, hey, listen, I'm running 500,000 and I'm going to be running at 80 feet. And the available fault starts at 24,000. What's the fault at the line side terminals of that service disconnect means? Because we need to know that information. So you do a calculation. There's a spreadsheet. There's a calculator that does that. And guess what? They say it's 21,050. Great. But you know what? The most common, well, I say most common, depending upon where you are in the world, but generally most gear is rated 10,000 amps available fault. 10,000. Well, if you have 21,000 available fault on the line side, then you better make sure you have equipment that is suitable for the available fault. That rule is 110.10. Okay? And then we also have to be worried about 110.9, that's interrupting ratings, but I'm not going to get there. Now watch this. We go from the service disconnect means, let's say, to a panel. Again, is it copper? Is it aluminum? What size wire is it? Is it in a metal raceway? Is it a plastic raceway? What's the impedance? What's the AC resistance? What's the reactance? What's going to be the effective impedance based upon a certain power factor? And no. And then you just get the software, you go 110 feet. It'll just say, 18,696 amperes. And then you say, hey, I'm going to go downstream. Well, then you know what? No, my point is this. The available fault starts at the power supply. Now, if you have a solar PV system, obviously it's limited because it's not like a utility with a huge amount of power. But that available fault keeps decaying as you continue cascading the system. But you know why? Because you keep adding reactants to that fault. And that's what it is. That's all covered in theory. All right. That was just a concept of that. Now, 110.16b in the code says, hey, listen, as the heading says, if you have a service of 1200 amperes or more, we need a label. Now, here's what we want on that label. We want to know the voltage. We want to know the available fault. And we want to know how long is it going to take for that protected device to clear. And we want to know what day did you put that label on there. You're thinking, how the heck am I going to get that information? Well, you need to know what you're doing. I mean, you're supposed to be the expert. You should know where to get the software to figure out the fault current calculation. You should know about getting the utility, doing the math, and you really need to take like a class on in this type of material. We cover this in my seminars, of course. We cover this because it's a code rule. So going a little further, then if you have this is going to be a circuit breaker with a clearing time. And you know why they want that information? See, because the code cannot require you to put an NFPA 70E label that will tell you the calories of the incident energy calories, any of the blast zones, arc flash zones, so that a person knows, okay, here's the protective gear I have to put on. And when I get within this area here, I have to do this. Well, the code can't, that's a 70E requirement, but the code can just say, okay, fine. But guess what? If you have that information, then you can go to 70E and you can extrapolate out what kind of PPE equipment that you should be using. Now that is services, 1200 amperes or more. 110.16b says, you know what? You don't have to do those calculations at all. Don't worry about it. If you can go to a 70E, using 70E, and you can put an arc flash shock hazard label on there that complies with 70E, well, then you don't have to do about all those numbers. So if there's going to be an arc flash study, incident study done, and they put those labels on there, then the electrician doesn't have to worry about making that calculation. The engineer's not going to do this. He doesn't. He's just drawing these plans, and he doesn't know what the heck's going on after that. So in the field, you have to put, this is a field label required. All right. So 110.16b has a note 1, and the note 1 is kind of giving you the information that maybe you need to take a 70E class. I do have a 70E kind of a book, and I'm working on making that a little bit better, and it's going to be a safety book, but it's not really ready yet. It is online, but it's not really ready in a Mike Holt, standard that I want it to be. So the code is just telling you, hey, that arc flash label, if it complies with 70E, then you don't have to do that. I'm like, oh, okay, I see how it works. And then there's another rule, 110.24a, It says available fault current markings at service equipment other than dwelling units. This, see, 110.16b was talking about service equipment over 1200 amperes. 110.24a is talking about service equipment in general, which means it doesn't have to be over 1200 amperes. So if it's not over 1200 amperes, you still have to put the available calculation. You don't have to put the voltage. You don't have to put the time it takes for the protected device to open. You just got to do a calculation and stick that label on there and put the date you did it. So how do you do the calculation? Oh, Brian has given me some feedback. A lot of people asking what fault current is. I don't know how to explain that because this is not an electrical theory class. That's covered in electrical theory. And if you don't understand what fault current is, or interrupting ratings, or available short circuit current, you really need to take some time, go back and get some understanding in fundamentals. I don't have the time to be teaching a theory class right now. I'm just teaching the code. So I apologize that I can't do that. I only have an hour and I got to go on to the next topic there. So, yeah, but I can't do any more than that right now. I apologize. So now how do you do the calculation? How do you get it up? Well, take a look at the link here. Go to Busman series. I'm going to take a chance and clicking on that link and let's see what that does to me. So you can go to Busman. It's an FC2 calculator, but you really should have an idea what you're doing. You know, so you should understand what an arc flash is, what an arc fault is, what available fault current is, and it takes you to a website here, and there's a QR code. You can use that to get to it. So, you know, Busman is a great company. There are a lot of great companies out there. I'm sure other manufacturers have those, and if anybody has information, the other ones, let me know. You know, that way I can make sure I can populate that information to everybody else. Sorry, that's all I can do there for you. Dwelling unit service conductor sizing. I can't do a dwelling unit load calculation. Mike, how do you size? Let's see what the question was. Oh yeah, this was number one, having to do with how to size a conductor. Well, the first thing you have to do a dwelling unit load calculation to find out what it is. So let me go a couple slides here and let me just go there. Right now, or very soon after you watch this, go to your app store and look for Mike Holt Electrical Toolbox. And all you got to do is go there and you're going to click on service load calculation. Click on that and it's free. I mean, come on, listen. We get a lot of free stuff, guys. I hope someday you guys actually buy something from me, because if not, we're not going to be around to support you in the future. So, but right now, this is free. And so you can do a dwelling unit load calculation, and it does everything. It tells you the size service disconnecting means, the size overcurrent protection device. It gives you the service conductor size. It tells you the neutral conductor size. It tells you the grounding electric conductor size. It tells you what size raceway. It gives you everything, and it's free. But I still had a question, by the way. You should never depend on software. You should know how exactly that residential load calculation is done, because if you're going to take a test, you're not taking my app in there. Okay? So you need to actually know how to do it. And I got a book here, somewhere in here. The book that covers that is my exam prep. The exam prep book handles all of the electrical calculations you would need on anything in the electrical industry. I can't think of anything it doesn't cover. All right, let's go back to the original question that somebody asked me. Hey, Mike, the NEC lets you size the dwelling unit service conductors at no less than 83% of the service rating. A dwelling unit with an 800 amp main is permitted to have a conductor size at 83% of that 400 amps, 332 amperes. And if you go to table 31016, using the 2020 code as a reference, you go to the aluminum column on the right-hand side, you go to the 75-degree C column, because we are sizing the conductors to terminals. We're not calculating the ampacity of a wire in a raceway or a cable. We're just going to termination, so it has to be 75 C. And it will take, you can use a 600 kcm conductor, kc mil conductor, not kcm conductor, kc mil conductor, and it's rated 340 amperes. You know, I never really thought about this 83%. By the way, this 83% for residential It only came about because we used to have a table that told you 400 amp service. Matter of fact, look what it is. It had this table, 400 amp service, 600 kcm aluminum wire. They took that table out, I can't remember back, 2002, 2005, somewhere in there. They removed the table, maybe 2000, and maybe even 2011. They removed the table out and they said, you know what? We really want to give them an actual mathematical calculation. So what they did was they took the table, they went in the reverse part, and so this table is 83% of the service rating. In other words, let's go to a 200 amp service. A 200 amp service, okay, well, you can use 83% of 200 amperes, which is what, 176? I think that's what it is, right? 160, 816, 166. I think it's 166 or something like that. 200. Well, then you go to, it's 2 aught, and I think 2 aught's rated 175. Everybody's fine. So they got rid of the table to use the 83%. I submitted a public input, say, look, can we forget about the 83% and allow us to put the table back the way it was? So in the 2020 code, it brought it back. But in that process, I started thinking about this. Wait a minute. Look at that 400 amp service. You could use 600 kcm aluminum. What's the ampacity of table 31016, 400 kcm aluminum? It's 340 amps. How can you put a 400 amp breaker on 340 amp wire? There's no rule that allows that. Article section 240.4 tells us conductors must be protected at their ampacity. Then there's an exception, then there's a rule of 240.4b that says, well, if the ampacity of the conductor doesn't correspond to the standard size, which is identified in 240.6, that's how you get the standard size, you can use the next size up. Okay, great. But take a look at the slide here. And if you go to 240.6, there's a 300 amp protection device, a 350 and a 400 ampere. This is a violation of the code. And it blew me away that for 100 years, maybe more than 100 years, this has always been wrong. Because conductors must be protected at the ampacity, which is 240.4, but a totally different code panel in 310 said, you know what? We've had this panel for 100 years. The residential, here's the wire size you can use for residential, because we know that residential, you actually don't put the current that you calculate. I think, hold on. That's not an Article 310 deal. That's an Article 220 deal, and how you size conductors based upon the calculated load, continuous and non-continuous loads. You don't sit there and put a 200 amp service and run wires smaller than the rating of the overcurrent device and use the next size up rule. I submitted a public input to have this table removed and simply take the 83% that you're doing this calculation, go in Article 220. Do your load calculation and say, hey, you know what? We calculate 200 amperes, and when you get your 200 amp calculation, take 83% of that, and that's how you size the service. Then you size the protection at 83%, and then you size the conductor to the rating of the protection. So, back to the question here. Mike, the NEC allows you to use an 83% adjustment. But if you use the 83% adjustment, then the overcurrent protection rules are conflicted. And the answer is yes, that is true. And it's been that way for 100-something years, and probably nobody even thought about that. But I did, and they rejected my public input. So that's what it is. And of course, the easiest thing, do the app. And the app, hey, Brian, I wonder if my app is even right on residential load calculator. It has to be, but I'm going to have to check it tomorrow. We'll use the optional, but it. Okay, well, we're getting it. I'm just so you know, I'm listening to Brian telling me there was a question came up. I don't normally do this, but I'm going to try to do this to see if I can do this. Go ahead, Brian. Okay, there's another question coming in, not related to this specific thing, so I can't take that question. We can cover it, put it in a pile, and I'll cover it another time. I'm just covering the size of the wire. That's all I'm covering. All right, I'm going to move on. GFCI protection for a garage. I get a question coming to me, hey, Mike, I got a 6-bay garage, and, you know, the GFCIs and this and that, on and on and on. I'm like, what the heck fuck are you talking about? I asked the guy, I'm like, what are you talking about? Who has a six? I'm not saying people don't have 6-bay garages, but then I got more information. Here's what he said, which is something I never thought about. Mike, we have a firehouse with 6-bay doors, garage doors. Our inspector is requiring GFCI receptacles for the garage doors. These receptacles are 20 feet in the air. They're not readily accessible. If the GFCI trip, they will not be able to answer an emergency call. I'm thinking, well, 210.8B8 says any receptacle in a garage, doesn't matter how high they're located, doesn't matter where they are, but in the 2020 code, any receptacle, that means 240 volt rated receptacles as well as 250 volt rated receptacles as well as 125 volt rated receptacles have to be GFCI. But 210.8 tells us this. The GFCI test button, effectively what we're talking about, has to be readily accessible. Now you have to go to Article 100, read the definition of readily accessible, and it means that you can just kind of walk up to it. Don't have to climb over, don't have to get over this table to get to it. I don't need to get a 5-gallon bucket. I don't need a ladder. I don't have to get under the desk, to get to it, like in a dwelling unit. You have your dishwasher disposal, your receptacle. You couldn't put a GFCI receptacle underneath the sink. Well, because you can't remove obstacles. If you have to remove an obstacle, well, then it would not be readily accessible. The intent of this rule of the GFCI to be readily accessible is so that people can test it monthly. Now, the failure rate of GFCIs are about, I think it's 13% for receptacles, and I think it's about 11% for breakers. My point is this: all electronic devices, well, actually, everything has an end of life. Mike Holt, I don't know, maybe tomorrow, riding a mountain bike, I'm gone. Maybe I'm going to get some illness and something's going to happen. I don't know what it is, but I am going to have an end of life. Light bulbs have end of life. Motors have end of life. Everything has the end of life. You got to be real careful because GFCIs or electronic devices, they're very sensitive to overvoltage, which is an Article 242 of the 2020 code, having to do with transients from lightning, transients generated from inside the premises. We talk about this in the fundamentals class. And so you got to be real careful. As a matter of fact, the 2020 code is requiring in dwelling units, the rule is 23067, that all dwelling units services have surge protection. That means all new services effectively in the 2020 code and all replacement services. And the logic is that you have AFCIs, GFCIs, you have smoke detectors, you have sensitive electronic equipment in a dwelling now that we're depending on to protect the occupants. Well, you get a transient, it kind of it goes inside and it wipes it all out. So it's requiring surge protection. So back to what we're talking about. GFCIs and AFCIs have an end of life. So don't think that's like you're safe. It's just like, okay, test the button, verify that it's right. And because you have to test the button and always test that button, you need to be readily accessible. So back over to the question. Do those receptacles in the firehouse have to have GFCI protection? Yes. Could you use a GFCI receptacle 20 feet off the ground? Of course not. So what do? Just put a GFCI breaker. That makes the breaker guys happy. So not that complicated. By the way, I'm only going to go for 1 hour, hour and a half. Doesn't work for us. Brian is up till like 12 o'clock at nighttime trying to finish it off. And then he gets up super early in the morning and working. And I don't think it's fair to you guys. So we're going to stop at exactly 8 o'clock. And Instagram, guys, it's going to end a little bit sooner than 8 o'clock. So you can jump into mikeholt.com/live to watch the last few minutes. I might run a few minutes late, but not much. Okay. Okay, garage GFCI. You know what amazes me? Question is, hey, what about electric vehicle? Does that have to be GFCI protected? And I'm thinking, okay, how do I say this? I'll try it again. All receptacles in a garage have to be GFCI in the 2020 code. What about a welding outlet? All receptacles in a garage, regardless of the voltage and amperage, have to be GFCI protection. What about electric vehicle? All receptacles in a garage. Guys, you guys have a tendency to allow your experience, and here's what happens. You've never done something, and all of a sudden there's a requirement, and your brain can't even, like, whoa, but what about electric vehicles? And what about this? And what about if the receptacle was for a single receptacle supplying a single piece of equipment? Like, is it a receptacle? Is it in a garage? Yeah, okay, well, GFCI protect. It's just that simple, so don't make it complicated. You know the best thing is? Get your code book, please. I'm giving all these code references and I'm trying to remember them on the top of my head, and I think I've done okay so far, and if I make a mistake, will eventually find it. Guys, this is what you do for a living. You're an electrician. You don't know how to use the code book? You don't understand what fault current is? You're a master electrician, you're an inspector, you're a contractor, you're an engineer. Guys, the world is depending on you. You're the person that's going to protect those people from the hazards of electricity. And just so you know, there is not one electrical system out there that is safe. There is no such thing as a safe electrical system. Never tell anybody you checked your house. I am going to be those on the Instagram, it's going to cut out before I finish up tonight. So go to MikeHolt.com/live and watch it there. And so YouTube should be fine. Everything should be fine. Okay, back now. So the gentleman in Philadelphia calls me, and I can't, what are you talking about? He tells me what it is. He says, there's a local township inspector that is enforcing the placement of a floor receptacle along railings in a dwelling unit. And he was going nuts on me. And I'm like, and I couldn't believe he was asking the question, because it's like, if you read the rule in the code says railings. So here's the rule, 21052A. Now, 21052A gives us the replacement of receptacles, okay? And if you go to 21052, I think it's just 50, I don't think it's 52, I think it's just 21050. Boy, I haven't used a paper code book in a long time. 21052, what's 21052A2, this graphic, let me see if I got it here. Okay, this graphic is an A1, which talks about where you place receptacles in a dwelling unit. But 21050, see, we're talking about wall space. 21052A2 talks about the wall space, and 21052A2 3 says railings. In other words, if you have a wall, we know what a wall is. You need a receptacle along the wall line. If you have fixed panels, well, then, you still need a receptacle there. You can't put it in the glass, let's say, then you got to put it in the floor. What else we have here? We have the floor. You don't count receptacles that are above 5.5 feet when it's required by the code. Fixed room dividers, then you got to put them in the floor. So, yeah, if you have railings on a dwelling unit, that's wall space. You're going to have to put floor boxes in there. He goes, oh, man, Mike, I guess I got to apologize to a lot of people. I'm like, trust me, buddy, I've been there many, many times. So you may get used to it. Those of you who work in the electrical trade, please do me a favor. I'm an arrogant, condescending guy, and I got all kinds of problems. Ask my wife. She can give you a whole long list of what I am, okay? And I'm working on all of those. But one thing I don't have is pride. If I'm wrong, I'm going to tell you, you know what? I was totally, completely wrong. Because I want to learn. I don't want to be wrong, but I want to learn. So I'm hoping that you're going to learn something here, and you're going to stand up, and you're going to say, you know what? I said, call that guy back Tell him you're totally wrong about that. He goes, oh, Mike. I said, yes, call him back. That's what a person is supposed, that's character. All right. Got another question we can go to? And this one, I know, this is going to hit all the buttons for Neanderthal guys, okay? Neanderthal guys don't like aluminum wire. They don't like Gfcis. They don't like AFCIs. They don't like Romex. I forgot. Oh, yeah, they like ground rods driven anywhere. I mean, just drive a ground rod and they feel better about that, okay? That's the Neanderthal. Hopefully, they're going to be gone, you know what I mean? And you younger people are going to be in there knowing a lot more than they were. This has to do with Romex splice kits. I thought it was an interesting story. Hey, Mike, a maintenance guy drilled into the Romex cable, the NM cable. I repaired the damaged cable with a splice kit according to the manufacturer instructions. The splice kit was then concealed. Well, yeah, that's what you do, right? You drill a hole. Oh, man, you cut the drywall out. You put the splice kit in there, and they go back and they drywall it up, and it's fine. I'm like, okay. Now, 334.40b is in NM cable. It says a box is not required or a listed NM interconnector device. So it's called an interconnector device. That's the UL listing title of that. We call it splice kit. Is a box is not required where a listed NM cable interconnector device is used for exposed cable wiring or concealed repair wiring in an existing building per 300.15H. Whether it's exposed or whether it's concealed, it doesn't really matter. And I find this, Brian, make a note for me to make a public input to change this. I'm like, if you want to put this connector in a brand new job because you want to put it in a new job, that's a violation of the code. So wait till you get your final. Then go in there and then and put the splice kit in there and fix it in that case. Then it's okay. So that does, electrons don't actually know the difference between that. Okay, so this is fine. So now, here's what goes on in the story. My supervisor said that this was not allowed to be used for this purpose. I'm thinking, I'm sure he's thinking that, like, really? I mean, like, 334.40b says I can do this. The instructions, if you read the instructions, it says you can do this in the instructions. This is a listed product. And then the supervisor says, you can't do this. And I'm thinking, okay, I want to hear this story. When I cited 334.40b, he told me that that reference was never intended to be used for that application. Okay, let me read 334.40b. A box is not required where a listed NM cable interconnector device is used for exposed cable wiring or concealed repair wiring in an existing building. Exposed or concealed. Well, that's pretty much everything there is, right? I don't know anything else. I guess you can't put it in the ground. So I'm thinking, okay, well, that guy's an idiot to even make that statement. He said that the code requires all splices to be accessible and that clearly that splicing method was not accessible. I'm like, okay, well, you know what? The rule that talks about that all splices have to be accessible also has a rule about this interconnecting, what do they call that thing? An interconnector device, an NM cable interconnector device. So the rules having to do with when you make a splice, it has to be in a box, has a specific rule, which is 315H. Here's what it says. A box or conduit body is not required where a listed NM cable interconnector device is used for exposed wiring or concealed wiring repair in an existing building per 334.40b. I know that the Neanderthals hate this. And I'm thinking to myself, they make a device to make a splice to put in a wall in an existing, or basically it's going to be an existing facility. Of course it's okay, you know, but it's going to be concealed. I mean, if you go to 315H, I think they also have like an informational note, and they have references to mobile homes, to manufactured homes. These things are used all in the millions. RVs. If I go underneath and I work my RV a little bit, there's an interconnected device. All I can say is, take a deep breath. When you deal with somebody like this that's crazy, I know what you do. He's your supervisor. I know what I would do, but you don't want to do what I do. So let's go on. Well, I'll tell you what I'm doing, Brian. Could you want to play that one video for me? I don't know if you were set up, and I'll set it up if you're, all right. All right, Brian's going to set up a video for me, and then we're going to close it up for the end of the night. Those that are Instagram,